this is Britt Caswell with another example video. In today's video, I'm covering example 3 from section 9-1 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to use approximate solutions. Alright, so this is a nice golfing example. So Anastasia hits her golf ball off of a tee. The height of the golf ball is modeled by this function. Okay, so that means that the y-axis is the height, and x is the number of seconds after the golf ball is hit. All right, so the y-axis is our altitude or our height, and our x-axis is the time. How long is the golf ball in the air? So what's really nice about seeing it on this kind of graph is that this is very much modeled like you would imagine a golf ball would travel. And so you could see where that golf ball is in the air, and then you could see where it's touching the ground. And so if you can follow that, you could very quickly see that it's in the air for about 5 seconds. All right, so I'm going to answer the word problem with a word solution. The golf ball is in the air for approximately 5 seconds. Now, is it exactly 5 seconds? No, it's 5.04 seconds. But that 4/100ths of a second probably doesn't really matter to whoever is seeing this, okay? So it says, at the next tee, a golf ball was hit and modeled with this function. When will the golf ball hit the ground? And so I went ahead and I popped that bad boy on the Desmos. And you can see it here. So the time that it spends in the air, okay, here's one thing worth noting, is that the initial height here is 6. So this golf tee is 6 feet off of whatever ground they were on. So if this is like the golf thing, he was probably like chilling on like a hill like this. And he hits the golf ball off the hill like that. Okay, because hers, when Anastasia does it, her y-intercept is at 1, so she's not quite so flat as this. But anyway, so you could see here, you could also see the maximum height if you click on the vertex. So at 0.33 of a, or 3.344 of a second, this thing reaches its maximum height of almost 8 feet, okay? So it goes up a little bit, and then it goes down, 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 like that. That's his movement. Apparently he's hitting the golf ball at Anastasia. Oopsies. But the time that it's in the air, what you want to do is you want to look at it here. And so this back part of the graph that is before the time equals 0, this part of the graph doesn't matter, okay? Right? Because this is describing negative time, and negative time isn't really a thing, right? So we're only caring about the positive time that this thing was in the air. And so it's okay to ignore the fact that this other intercept isn't on 0, okay? So it takes about 1 second for this golf ball to hit the ground. Alrighty, so there we have it, y'all. That is how to use an approximate solution in a golfing example. Until next time.